evaluate the following definite integral. And we have the definite integral from pi by 6 to pi by 3 of 4 sine of 2 theta cosine of 2 theta. And so looking at this, we don't have a general antiderivative for this, but we do recall the double angle formula. So we can rewrite the integrand using our double angle formula so that it becomes a general antiderivative. So again, let's let k be some constant value, some real number. And the double angle formula tells us that sine of 2k theta is equal to 2 times sine of k theta multiplied by cosine of k theta. So we'll now use this to rewrite our integrand. So let's think about what we're given here. We have 4 sine of 2 theta multiplied by cosine of 2 theta. So we can rewrite this as 2 times 2 sine of 2 theta cosine of 2 theta. So if we look back up at our general formula here, we realize that this k for our general antiderivative, or our integrand, is 2. So that means we're going to have 2 times theta for the equivalent trig identity. So this will be equal to 2 multiplied by sine of 4 theta. And so now we look at this and we realize, hey, that's a general antiderivative. So we've taken the definite integral from pi by 6 to pi by 3 of 4 sine of 2 theta cosine of 2 theta d theta. And we've rewritten in its equivalent form the definite integral from pi by 6 to pi by 3 of 2 sine of 4 theta d theta. And we're ready to integrate. And so this integrates to 2 multiplied by a minus cosine of 4 theta divided by 4. And we're going to evaluate now from pi by 6 to pi by 3. And we can simplify. We know, of course, that 2 goes into 4 2 times. So this leaves us with a minus 1/2 multiplied by cosine of 4 theta. And we're ready now to evaluate from pi by 6. Oop, and shame on me. This upper bound in the previous step should be pi by 3. So our bounds are pi by 6 to pi by 3. So let's evaluate. We have minus 1/2, and I'll keep that on the outside. Minus 1/2 of cosine of 4 multiplied by pi over 3 minus cosine of 4 times pi by 6. And we can simplify. This is equivalent to negative 1/2 multiplied by cosine of 4 pi over 3 minus cosine, and both 4 and 6 are divisible by 2, so we can simplify that to 2/3. So that's minus cosine of 2 pi by 3. So we use these trig identities less frequently, so if we think about our unit circle, so we know, let's say, here is pi by 3. We know here is 2 pi by 3. Here is 4 pi by 3. So, of course, we know that the evaluations are again for this theta here. That's where our pi by 3 is. We know that our evaluations in quadrant 1 leaves us with a cosine value of 1/2. And sine, of course, is the square root of 3 over 2. But we're only concerned with cosine here. And then depending upon the quadrant that you're in, the signs will change. So we have minus 1/2 multiplied by, we have cosine of 4 pi by 3, which will be minus 1/2 minus cosine of 2 pi by 3, which is also minus 1/2. And so we have negative times a negative gives us a positive. So we have negative 1/2 multiplied by minus 1/2 plus 1/2, which is 0. So this leaves us with a beautiful final answer of 0.